This is a video for the Physics 1050 lab, Momentum and Impulse. The theory in this lab is very straightforward. We're going to be talking about momentum. Momentum has a symbol of P. Momentum is equal to mass times velocity. Momentum is a vector. It has the same direction as velocity. Impulse is related to momentum. Impulse I is the change in momentum. Change in momentum means final momentum, subtract initial momentum. And our last little bit is that impulse is change in momentum. Impulse is also any net external applied force times length of time. Okay, let's talk about this for a moment. When we say impulse is change in momentum, we mean the change in momentum before and after a collision. So Pi is the momentum before a collision. Pf is the momentum after a collision. When we say impulse is force times delta t, delta t is the length of time it takes for the collision to occur. That's generally a very short time. And F is any applied or external forces during the collision. So a force from outside, for example, perhaps friction. If this external applied force is 0, so if there are no external forces, then we say momentum is conserved. If momentum is conserved, ways we typically write that as an equation are first, we might say Pf equals Pi. So that's one way we might write it. We also might say that our impulse, change in momentum, is equal to 0. So there's the theory of today's lab. Those are the things we're going to go through. So next, let's get into the apparatus and setup. I'm going to move the camera, so close your eyes if that's going to make you a little dizzy. Okay, let's make sure I've got the angle right here. Okay, I think this has everything in it now. So in our apparatus, what we have is a motion detector and the cord to connect it to our Lab Pro. We've got 2 carts. We're going to call them cart 1 and cart 2. Cart 2 has the plunger and cart 1 does not. We've got 3 black blocks, a plastic reflector card, a track, and some tape. So to get started with our apparatus, let's take our track and let's make sure it's level. The best way to make sure it's level is just put it on there, give it a little push. If it has no preferential motion, if it doesn't want to roll down or roll back, then we know it's level. Okay, here's a bit a lot of students miss. Cart 1 has 1 block in it, so that goes in like this. Cart 2, you can push that plunger in if you wish, has 2 blocks in it. You might notice that your carts and your blocks, they all have labels. And then this magnetic strip on cart 2, we're going to put that facing cart 1. Okay, so there's that bit of setup. We're going to take our plastic card. We're going to take it so that the long end is up, not sideways. We're going to take our plastic card and tape that onto the front of cart 1. Okay, so I've got some tape on there. Tape it on there. When I put my card on my cart, I want to be careful that this plastic card doesn't touch the track. So the bottom of the card should be about flush with the bottom of the cart. And you want to tape that on nice and securely. If this wiggles during the experiment, then we might get some funny results. Next, we are going to plug in our motion sensor. So this says DigSonic. I'll plug 1 cord in here. I'll look for the DigSonic on my Lab Pro. This is my first thing I'm plugging in, so I'll plug it into port 1. That's now connected. And I'm going to take my motion sensor and put it so that this round gold foil is facing the card. Okay, I'm all set up and ready to go. Now I'm ready to collect my data. So when I collect my data, I'm going to open up my Logger Pro. So I'll come here, I'll click on this link right here, and it's going to open Logger Pro for me. Oh my, once in a while there's a little hiccup. We can work around the hiccup. Okay, here's our Logger Pro. This opens. We've got one graph. It's position versus time. So now what I'm going to do when I collect my data, it's important that you do this correctly. It's easy to make a mistake. So our two carts are separated by a little distance. Our cart 1 is close to the motion detector, maybe 35 or 40 centimeters apart. I'm going to hit the collect button, then I'm going to take cart 1 and I'm going to push it towards cart 2. Some people get that mixed up and they push 2 towards 1. We want to push 1 towards 2. When I push, I want my hand to be behind the card because I don't want my hand to interfere with the motion detector. Okay, so I'm going to hit collect. I hear it click. And I'm going to let it run. Okay, so now I've got my data collected. If I'm looking at my data and I'm thinking about what is happening here in my experiment, right here, it's at a constant position. So that's the cart before I pushed card 1. So cart 1 is not moving. It's at the same place. That's this right here. This little bit right here, this is where I pushed cart 1. I got it moving, so I got that moving there. This part right here, this is the motion sensor reading the motion of cart 1 as it's going towards cart 2. We might notice here that that's pretty linear. It's moving with approximately constant velocity. This point right here, the velocity changes. If we ask what makes the velocity change, that's where cart 1 hits cart 2. Okay, so that's where things changed. So that point where they collide is this point right here. And after that, the two carts are moving together. Again, this is pretty linear, so it's going with a straight line motion. Okay, so here's our collision. This is before the collision, and this is after the collision. So that's our apparatus. That's our setup. Let's go through. What else do we need to talk about? As we get into our analysis of this lab, we'd like to find the momentum before the collision and the momentum after the collision. So we'll need the velocity before and after the collision. To get our velocity before the collision, okay, and this is the part where some students get astray, what we'll do is we'll put our mouse right on top of the collision, we'll click, and we're going to drag to the left, and this part is really important, it's even in bold in your instructions. We're only going to highlight 10 points, and you can count them off in the table, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Once you've got your 10 points highlighted, we're going to do our linear fit, so you can click Analyze, then Linear Fit. That's going to pop up a linear fit to this portion we've highlighted. It tells us the slope. We'd like to get our uncertainty, so let's turn on uncertainty, and I'm just going to make that box a little bigger so it's easier to see. Okay, so my slope is 0.2567 plus or minus 0.0006. We see here that the units are meters per second. That shows us that the slope is our speed, and that's what we expect from a position versus time graph. So this is the speed of cart 1 before the collision. Remember, before the collision is just when cart 1 is moving. So before the collision, cart 1 has a slope or a speed of 0.2567. Cart 2 is not moving yet, so that has a speed of 0. Okay, that's before the collision. What about after the collision? So for after the collision, we want to do a similar sort of analysis. We'd like to get the speed afterwards. So we're going to put our mouse on top of the collision point, and we're going to highlight 10 points to the right of the collision. Okay, so I've highlighted my 10 points. I can count them off in the table. I want the speed, so I'm going to do the linear fit. I want to know the uncertainty of my velocity, so I'm going to turn that on. I'm going to make that just a little bigger so it's easier to show up. We'll say okay. And I see here that my slope or my speed after the collision is smaller. It's 0.09891. So this is the speed. So we've done our collision, the carts stick together and they move together. This is the speed of both carts together. Okay, so when we calculate our final momentum, it's moving together all as a system. So the mass is the total mass, and the speed of the whole thing is our speed from our slope right here. Okay, hopefully that's clear about how you're going to do your analysis. That should take you through your tables 4A and 4B. When you do your analysis, we're going to find the total momentum before the collision. So that's just the cart one moving by itself. We're going to find the total momentum after the collision, the total mass with their combined speed. And we're going to see if those momentums are the same or different. If the momentum are the same, then momentum is conserved and there was no external force. If the momentum is different, then momentum wasn't conserved and there must have been an external force. So our experiment today will talk about those things. When we get to question 4 in our analysis, we're going to treat our system. We're going to look at that interaction carefully. So at the point of the collision, at our collision time, cart 1 bangs into cart 2. That's the collision, that's smacking together. So question 4 asks us to think about the carts individually during the collision. So as cart 1 comes up and hits cart 2, our question is there a force on cart 2? I would have to say yes. Cart 1 hits it. So cart 1 exerts a force on cart 2. One of our questions is there a force on cart 1? When I think about Newton's second law, if cart 1 hits cart 2, then cart 2 must hit cart 1. So I think there's a force on each one. I think 1 bangs into 2, and 2 also exerts a force on 1. And from Newton's second law, those forces should be equal and opposite. So then we're going to think about impulse. If the forces are equal and opposite, does that tell us anything about the impulse on the 2 carts? So I'll let you think about that as you apply your theory. You'll also do some calculations and see if you can back that up. Okay, that should take us through the momentum and collision lab.